Hi, Assalamualaikum. My name is Muhammad Akwan bin Muhammad Asri and my metric number is DE180088. So at here, I am the first presenter for our group, which is group 5. I would like to present the assignment 2, which is Recyclable Material Classification by using Convolutional Neural Network, CNN. So for the introduction, the Convolutional Neural Network, CNN, is one way to obtain the dataset and also known as a ConvNet. CNN commonly used to analyze visual imagery and are frequently working behind the scenes in image classification. The CNN can take in an input image and assign important learnable weight and bias to various objects in the image and able to differentiate. And last, the pre-trained model that has used in this project is CNN, VGG16 and TensorNet. So then I would like to introduce to the convolutional neural network CNN first. So CNN is a deeply learning algorithm which can take in input image, assigns important learnable weight and bias to various aspects and objects in the image and be able to differentiate one of the others. So then CNN have the ability to learn those filter and characteristic. And the most benefit aspect of CNN is reducing the number of parameters in artificial neural network. Then we go to the methodology. So for the methodology, our group use a flowchart. So for task 1, which is we start then loading data from the Google Drive and then training a sample. After that, we're doing the convolution layer, max pooling, then we repeat again convolution layer, max pooling, convolution layer, max pooling, then dense and CNN-based feature learning, training sample features, image clarification, and output clarification result, and end. So then we go to the demonstration at the collab notebook. So for the demonstration, and this is the collab notebook, and this is for the task 1. So we go through for step 1, which is we connect to the Google Drive, which is here. So make sure in our Google Drive, we already upload our folder, which is for the dataset, and inside the folder dataset we have test folder, we have training folder, and we have validation folder. So then for the step 2, we need to feed a dataset directory, and then for the step 3, we create a training and a validation data directory. At here we need to change our directory depend on our database, so Google Drive. So after that we run and we get this result. And then for the step 4, we doing the construct the CNN model and training model. So at here we using input shape, which is 115, 115, and 3. And then this is the result for the model sequential. And then for the step 5, we pre-process the input data. And so at here, our target size is 115 and 115. And at here, we're using batch size is 8. So the result for this is we found 466 images belonging to 2 classes and found 210 images belonging to 2 classes. And database sheet is 8, 115, 115, and 3. And label batch sheet 8. And then for the step 6, we start training process. So at here, for the step per push, we use 5, and ePush we use 10, and then last for the validation step, we use 10. So this is the result that we get. And last step is step 7, which is plot the outcome. Then this is our graph that we get for the training and validation accuracy and training for the validation loss. So then we continue at the slide presentation. So next, for the result and analysis. So for the task 1, this is our graph that we get for the training and validation accuracy. So at here we can see our graph is optimized but not exactly optimized, and our training accuracy we get is 95.75%, and the validation accuracy we get 85.38%. And next, for the second graph, which is a training and validation loss. So at here, after we done the calculation, and we get a training loss, we get 14.47%, and the validation loss we get 74.157%. So I think that's all from me. Thank you.
Assalamualaikum and Hi, my name is Nurul Rafiqah binti Razuhi. My metric number is DE180085. For this assignment 2, I want to present task 2. So in this task 2, we need to use transfer learning concept. So actually, transfer learning concept is the reuse of a pre-model on a new problem. So for transfer learning, the knowledge of an already trained machine learning model is applied to a different but related problem. So for this task 2, we need to select two pre-trained model, and then we have decided to choose, which is we choose VGG16 and then SNET 1-to-1 model. So I will present about VGG16 model. Okay, actually VGG means Visual Geometry Group. Number 16 is referred to it has 16 layers that have weight, and then VGG16 also known as Oxford net, and then it has total around 138 million parameter. Then VGG16 is that instead of having a large number of hyperparameter, they focus on having convolution layers of 3x3 filter with a straight one, and always use same padding and max pool layer of 2x2 filter of straight 2. Actually, it follow this arrangement of convolution and max pool layer consistently throughout the whole architecture. So as you can see in this picture, in each convolution we'll use ReLU. So actually, ReLU means linear rectifier function, which is an activation function for the neural network. And then in the end, it has two fully connected layers that follow by softmax for the output. Okay, next is methodology. So to do this task, we have followed this flowchart. So first of all, we select our pre-trained model, which is we select VGG16. Next, by using the Google Colab, we need to construct CNN model. So which is we construct our VGG16. So first, we need to load the data from the Google Drive, and then we import the relevant file. After that, we need to construct the pre-trained model. Next is we need to fit the constructed pre-trained model to the structure architecture by using a specific command, and later I will show you. Okay, next is we need to pre-process the input, and then we need to setting the step per epoch and validation step to start our training process. And then to have the result, we need to plot the outcome of our CNN model. So now I will show the demonstration using the Google Colab. So this is Google Colab interface. Firstly, make sure that our notebook is connected by see the icon appear here. Okay, which is RAM and disk. So for the first step to do this task is connect to Google Drive in which the dataset is stored. Then the Google Colab will read the data and perform the training session. So basically my data is stored like this way, which is from Google Drive, go to my drive, and then go to the Colab notebooks. Okay, after that, it has a dataset folder. Under this dataset folder, it contains three folders, which is training, validation, and testing. Okay, so for the training and validation folder, it has two types of the data, which is CAN and PAT. Okay, So to connect our Google Drive to Google Colab, just click run button here and then it will show some note here. So in this case, it shows that my Google Drive is already connected to the Google Colab. Second step, we need to feed the dataset directory. So this orange link here, we actually is from my Google Drive. So to have this, just click here and then click here after copy path here and then just paste above here. Then you need to run. After that, for the step 3, we need to create a train and validation data directory. So as you can see here also show the orange link. So just do the same step as I mentioned before, which is just copy path for the folder that you want. Okay, then click run button here. After run, it will show the value of the image that we fed to the directory. So it show that for the training, the CAN is 156, for the PET is 310. For the validation, CAN is 77, for the PET is 133. After that, this is the image that my own image that I fed to this directory. So which is 3 image. Okay. Then at this part, we import the relevant library, which is TensorFlow. Actually, TensorFlow is an open source framework that developed by Google Research. And then for the class here, um, which means a deep learning model that are made available alongside pre-trained weights. Then for the step 4, we need to construct the pre-trained model with VGG16. So this is the command that we use, and then click run button here. After that, it will show the whole structure VGG16 architecture. And then we need to feed the pre-trained model into the structure architecture, and then click run button here. Then it will show the summary of our system, which is for the first model is VGG16. Then flatten the output VGG before fed the dense model 2 and dense model 3. And then it also shown that the value of trainable parameter and non-trainable parameters. After that, we need to pre-process the input data. So in this command, we set the target size is 150150, meaning that all image will be resized to 150 multiply 150. And then for the batch size, we set into 20. Actually, for target size and batch size, we set for both training generator and validation generator. So then just click run here. It will show that it found 466 image belonging to 2 classes, and it found also 210 image belonging to 2 classes. And then for the next step, we need to start the training process. So at here, we need to set our own value for the step per epoch, which is we set equal to 5. Value for the epoch we set equal to 15, and then the value for the validation step equal to 10. So actually when we decrease the value of the step per epoch, it will be our task or our epoch will be it will be fast running. Okay, sorry, it will be fast running. Then as you can see here, to complete one task, it take actually around 1 minute and above. So for the validation accuracy, we can see that the highest validation accuracy is 100. So after we complete this step, we need to plot our outcome. So as you can see, this is the whole training session that it show that the whole training session, and then the plotted data is actually from 0 to 15. We have this epoch data is because we already set at this line. Okay, so that's all for the demonstration. Next, I will show the result and analysis for this training and validation accuracy and loss. So, this is the result for pre-trained model VGG16. So, actually this training process, the highest validation accuracy is 100%, and then the highest training accuracy also is 100%. So actually the appropriate number to pass on this existing training data is 15 epoch. Then the batch size is 20. And as a result, it's shown that the average training accuracy is 96.75%, while the average validation accuracy is 90.9%. And then we can conclude that our result for the pre-trained model is much more better than the task one. Okay, because for the VGG16, it has a higher validation accuracy compared to the validation accuracy in the task one. Next is for the average training loss, is 1.21%, while the average validation loss is 30.17%. So this model actually we can set as an optimal, even though it has some noise movement at the middle of the training loss and validation loss.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adham bin Mokhtar and my mentor number is DE180067. So for this assignment 2 for subject BEJT 4202 Vision System. So I will present about for my task, which is DESNet. Okay, so I will introduce to densely connection convolution network, or DESNet 1 to 1. So DESNet is a sort of convolution neural network that makes us to of the dense connection between layers through the dense block, which connect all layers. Specifically to improve the deadline accuracy caused by the vanishing gradient in high-level neural network. Okay, so for the methodology, so this is the flowchart for the DESNet. So as usual, we begin from the start, and then we pre-train by using DESNet. And to construct the CNN model, we just loading the data from the Google Drive. Next, 2D convolution layer. Furthermore, we use max scrolling, and finally we use flatten and dense. And for the next, we pre-process the input data, and we set the step per push. The push that I use is the value is 5. A push I use the value is 25, and the validation step to start the post, and the validation step I use 6. And then for the outcome of the CNN model, and we end the program. So I will at the collab notebook. Okay, so I will continue. So this is our DeskNet model. So for the first step, we need to go to Google Colab and find the data, and we just simply run. And then and also we need to find the data set from our Google Drive. And then next we need to find our uh, for example can folder and pet folder, and you need to put in this. Okay, so for the next we need to define for the DeskNet. I use DeskNet 10121 from keras.applications.desknet import to DeskNet 121. And next we need to do a convolution 2D, max pooling and flatten. So we get result like this. So the total of parameters that we get is for DeskNet is 19034.177. And next we need to do a convolution base for DeskNet 121. So we have a many result here. Okay, so next we need to do a rescale. For the class mode that I use, I mean the batch size that I use is 20. And before we get the result, the actual result for the validation loss, validation accuracy, we need to do the step here, which we need to determine the step per approach, which is I use is 10. For the approach, I use 25, and the validation steps is 6. So this is the code to get the output of to get the waveform. So this is our result for training and validation accuracy, and training and validation loss. Okay, so this is our result for task 2 DeskNet. So we can see that at the left side for the training and validation accuracy. So for the training accuracy, we get 98.24%. For the validation accuracy, we get 96.76%. At the right side, you can see the training and validation loss. So for the training loss, we get 0.64%, and last validation loss equals to 48.78%. Okay, so for analysis that we get from for task 1 and task 2, consequently, when they compare to the two models, CNN and VGG, and also the DeskNet, so we can see that the DeskNet model obtained the best accuracy. Because of the accuracy for the DeskNet, we can see at the table, we get 96.76% for approach 25. So based on our task, for three model utilize the same image for the Google Drive folder, and the DeskNet model in the task 2 is the best model for aesthetic featuring for the feature with highest accuracy and the least loss. So we can see that the DeskNet also have the least loss, which is 0.64% compared to CNN 74.57%, and VGG is 30.17%. And also for accuracy, CNS compared to CNN, CNN for accuracy is 98%, and for the VGG is 90.9%.
In a conclusion, we had learned on how to use Google Colab to accomplish our assignment 2, which is to recyclable material classification by using a convolutional neural network, which is CNN. And then we are also able to explore more about CNN and discover the architecture of VGG, which is Visual Geometric Group, and then the DenseNet, which is Densely Connected Convolutional Network Model. Furthermore, the system can accurately detect picture when presented with image of the PET bottles and aluminium cans, which is provided to us. In operation, it using multiple filters which can extract features from a dataset through which their corresponding spatial information can be preserved. The pooling of the operation, also called as subsampling, which is used to reduce the dimensional of the feature maps from the convolutional operation. For the VGG16 is actually 16 layer architecture with a pair of convolutional layers, pooling layers, and at the end is the fully connected layer. For the VGG network is the ideal much deeper network and with much smaller filter. Finally, the DenseNet is designed maximize the residual mechanism by connecting every layer, which is the same dense block, to its succeeding levels. It is because the acquired characteristics are all shared through a common knowledge. The model's compactness makes them non-redundant. Thank you.